Now, these particles arrive up to our Earth, and here you see some of them in this picture. And what happened when they enter the atmosphere? They split. Yes, and somehow they split. Why do they split? It's not really the reason why they split. The magnetic poles make them go in different directions. So they might go more at the poles because they're attracted by the magnetic field. And that's why we see the auroras in the aurora borealis and aurora australis.
It's just because the atmosphere, it slows it down and then the force of it breaks it.
Yeah, somehow it's the effect of the atmosphere. So the atmosphere, you have to think that it's like a wall of 1 meter thick, of water. And so you have to imagine that it's much more dense. They move from a material where it's almost empty to something that is much more denser. So we have lots and lots of particles. We have oxygen, nitrogen, all the elements that compose our atmosphere. So these particles, when arrive, it does like when you play pool. Do you play pool? Have you ever played pool? Not yet? Yes, say the truth. Yes, okay. So you see, when you kick the white ball and it goes into the other balls, it spread all of them around, right? And here is the same. If you look at it, it's exactly the same. So they have all these particles with less energy than the original one, but they get accelerated because of the kick of the cosmic ray. So they generate what is called a shower of particles. And the more you are up in the atmosphere, the more particles you are able to see. The more you go down, and at the sea level, the less particles are able to reach the sea level, because some of them get absorbed by the atmosphere. Not all of them get accelerated to be able to reach the sea level. So where are you going to get more particles? Here, or if you go up in the Mauna Kea? Sorry for my accent, Mauna Kea. No. But you are perfectly right and correct. Very good. Very good. Here is another view of the air shower. If you are on the ground and you look at the air shower from the ground, and you see all these tiny little houses, these are detectors that are measuring these particles, so that from measuring all these particles, we can assess what was the original particle at the beginning, the energy of this original particle at the beginning. So we put all these little houses where? Up, right, in the mountains, because we want to get as many as possible. And then these showers are super big. Depending on the energy of the cosmic rays, are very big. Imagine that the detector that is called a Pierre-Auger detector and is in La Pampa. Do you know where is La Pampa? No? No. Argentina. Argentina. Olé. So in La Pampa, Argentina, we have Pierre-Auger Observatory that is 2 times the dimension of Oahu, of the entire island of Oahu. So it's a huge detector. Then there are cows hanging around because, you know, you just need to have detectors here and there. So you can have your normal life and the detectors just take data without taking care of what's going on around them. But in our case, the guy, myself and the people working with me, we are working in a different type of detector that is in space. You see here how beautiful it looks. Oh, it's amazing. So he's on the space station outside. You see here the Earth, and he's looking at the outer space. And so I ask you now a question. Why do we, since we can measure these particles also on ground, why they need to go to space? Let us answer also, yeah.
Because in space, the particles haven't split through the atmosphere yet, so that's why you can collect more data.
Exactly. So like this, we can measure. Was it your idea too? Fantastic. Good tip. So it's because in this way, you can measure the particle before it enters the atmosphere, so you can get the original particle. Because you know, it's like when we say before about playing pool, it was the white one who kicked all the other ones. But if you are down there, you see all the other colors. Do you really measure the white one? No. But if you go to space, so at the top of the atmosphere, you can measure the white one, so the real particle, and you can understand if it was a proton, a carbon, or helium, or whatever, or something new. Who knows? We are in space, open-minded to discover new things. So here is the location of AMS. You see it's in the external RAS of the space station. The space station is, how big is this? A football field, as big as a football field. And we have here our experiment. Here are the modules where there are the astronauts. This one, what are these things outside here? Solar panels. Indeed, it's complicated to have power in space, right? So we get power from the solar panels. And here is our detector that is 16 feet times 13 feet times 10 feet, and is 15,000 libs, so 7 tons. It's very big. It's pretty big to be an experiment in space. And the power consumption is just 2.4 kilowatt. That is a bit more than a washing machine. So as you see, we needed to do a special electronics able to not have so much power consumption. Then how did we brought up AMS on the space station? The current spacecraft are not big enough to bring AMS. And we knew that the space shuttle was going to retire it soon. And so we were building up the instrument and hurry up in putting everything together, testing everything before the space shuttle retired, because it was literally the only thing that could bring up our experiment in space. And indeed, this happened. We made it in time, and this happened in May 16, 2011, with the Space Shuttle Endeavour. At this time, I couldn't be there by myself, unfortunately, because do you know where the Space Shuttle get up in space? From where? Florida, yes, Cape Canaveral, right? You heard maybe from the movies or things like this. And do you know instead where is the control room? Where is the control room if you need to control things and you need to make actions? In Houston. Houston, we have a problem, right? This is famous. Houston, we have a problem. So Mia was in Houston while my little baby was going to space from Cape Canaveral. It was, yeah. But we could see it and view it in a huge monitor that they have it there. So it was fine. And plus, everything worked pretty well. And here you see our experiment installed, and with 2 astronauts, you see, hanging around, putting together things. And we start taking data after a few hours that we were there. You can imagine that we were so stressed out. Oh my God, is it going to work? Is it going to fail? We spent so much time and effort in this detector, but it worked well.